Welcome back to BeeGraphy. In this BeeGraphy tutorial, we'll design a tubular pavilion using parametric tools and a graph mapper, combining math and creativity. This BeeGraphy tutorial shows how to design a parametric tubular pavilion with a graph mapper. Learn to manipulate points, curves, and control parameters like width, height, gap, and count to create dynamic, customizable structures. Ideal for those interested in computational design and algorithmic modeling in architecture. We begin by creating a simple point. This point will be the origin for our design. Using a linear array, we duplicate this point multiple times, creating a row of points. The count parameter decides how many points we have, which will eventually determine the number of tubular sections in our pavilion. Next, we adjust the position of these points. We use a gap parameter to control the spacing between them horizontally. A vector x node, multiplied by the gap value, moves the points along the x-axis. Now, we will move the selected points along the vector z direction. The vector z node will control the height. Now for the exciting part, introducing a curve. We use a graph mapper to control the vertical displacement of the points. To control the number of points, we will use the sequence SEC node. The list sequence SEC will be defined within the range of 0 to 1, and the quantity will be equal to the number of points, creating the points along the chosen graph curve. The graph mapper defines the vertical profile of the structure. Using bounds and remap numbers nodes, we scale the graph's output according to the height parameter, ensuring our design fits within the desired dimensions. The height value will be defined using the range input node. And with the obtained value, we will move the points. Now, we need to move the displaced points along the vector y direction and define the size using the range input node. This size will be the width of our pavilion. We also move the initial points in the same direction and with the same size. Now we will create a curve using those points with the polyline node. Let's use the graphed tree node to separate each element among the points. And with the grafted points, we will construct our curve. To give the curves a surface, we will use the pipe node. We have obtained one side of our pavilion, and to get the other side, we will rotate the part we have obtained by 180 degrees, which we will convert to radians using the deg to rad node. The center of rotation will be the center of the pavilion. First, we will determine the center of our pavilion by creating a new point whose x-coordinate will be the gap multiplied by the number of curves, representing the total length of the pavilion, and dividing it by 2. The y-coordinate will be half of the pavilion's total width. To get the correct distance between the arcs, we will move the rotated part by half the measure of the arc distance in the opposite direction of the vector x. The final touch involves enhancing the visual appeal of our spiral tube by applying material properties. The Apply Material node allows us to structure a realistic appearance by setting parameters such as color, metallicity, roughness, and opacity. We will move the variables to the left for better convenience. Select the nodes, right-click, and choose Hide to remove unnecessary geometries. Thanks for watching. We hope this tutorial helped. For more on computational design, please like this video, subscribe to our channel, and hit the bell icon to get the notifications. See you in the next tutorial.